Alright, so in this STEM problem solving walkthrough, we are going to be solving a MATHCOUNTS School competition problem. This is a 2020 MATHCOUNTS School competition problem, so all the problem credits goes to MATHCOUNTS, obviously. Now, Jay's dog, I'm going to read the problem. Get started. Jay's dog outgrew his rectangular pen, which measured 10 feet by 14 feet. Alright, to make it larger, he increased each side length by the same amount. We'll call that X. What he increased the side lengths by, which increased the pen's area by 81 square feet. So we have a rectangular pen here. Now this is the original pen. We have 10 and 14. And the area of this is 140. But then the dog outgrew this. So now we have a new one. And we're increasing the pen's side length by the same amount. So we have 14 plus X and 10 plus X, which increases the pen's area by 81 square feet. So originally it's 140, so essentially we have 14 plus X. The area of the new pen is 14 plus X multiplied by 10 plus X. And this increases the pen's area, the original pen's area, by 81 square feet. So we add on 81. What is the greater side length of the larger pen? So in this case, the greater side length is 14, but this is not the larger pen. We want to find out this side length. The 14 plus X is what we're trying to find. Now, let's just start off by realizing that we have 140 plus 81 is 221. So we have 221 over here. Now I want to add this to our equation over here. This is nothing but a product of binomials, and it's equal to 140 plus 81, which gives us that's going to give us a 221 over here. Alright. So far so good. Now we can just expand out the product of binomials. It's gonna be a 140 over here. This 14 gets multiplied by that. We get a 14x. This becomes a 10x. Everything is positive. Then we get an x squared term equals 221. Now this right here is a polynomial equation. Let's transform this equation into something we can handle. 14x plus 10x, that's 24x. And it's positive. 4x. And then at the end we are going to have our 140. Now this looks like a quadratic. This is a polynomial equation. Now we're going to bring the 221 subtract off. So what we're going to do is we're going to do 140 minus 221. Now 221 minus 140 is 81. We have a negative and that's greater, so we slap on a negative. And now we've transformed this into a proper x squared plus 24x. And now the constant will be negative 81, the constant term. And now we have 0 over here. We have no terms. And we've successfully transformed this into algebra. We've successfully transformed our geometry problem into an algebra problem. We have a quadratic here, and now all we need to do is use the quadratic formula. Now I'm going to erase everything but our quadratic, since we already know how to handle this problem now. And once we've found x, we just need to add x to, so what we need to, once we've found x, once we've figured out what x is, we just plug in the x over here. We just plug in our x, and we have the greater side length of the larger pen. We have the questions asking. Now let's solve this quadratic using the quadratic formula. Now we have quadratic formula, if you forgot, it's minus b plus minus I've done a video on this, so as a prerequisite, watch that video before you consider doing anything else. Now the a is going to be 1, so we can just eliminate the a. So negative b, we have b is 24, so minus 24 plus or minus, we have a root over here. And now we just have 24 squared. You can square 24 by using a product, by squaring a binomial. And I'm just going to square this in my head just so you can see my 4s. 4 times 500, yes, 576. So we have we're squaring b squared, 24 squared. That's going to get us 576. Now we have minus 4a. See, we have a minus 4. A is just 1. C is negative 81. Now this is the same thing as 81 multiplied by 4. 81 multiplied by 4 is just, let's just do it right here. 81 multiplied by 4. I'm pretty sure it's, yeah, 324 is the answer. So we have 576 plus 324. Now we know we're gonna have real roots since this, so we don't have to deal with any imaginary or complex numbers. And in the bottom, a is just 1, so we have 2. Now let's add 576 and 324 up and see what we get. Hopefully we get a perfect square as solution. I think we have 900. Now, square root of 900 is 30. 3 times 3 is 9. Slap on 2 zeros, you get 900. So we have minus 24 plus minus root 900 over 2. Root 900 is just 30. So I'm going to erase some of our work over here. We don't need this. Definitely don't need this. Don't need this. Don't need our square. We already know the quadratic formula. Alright, there's much more space. Now minus 24 plus or minus square root of 900 is 30, so we have 30 over here over 2. Now we can just pull out some common factors, and that's 15. So we have negative 12 plus or minus 15. Now this will lead us to an answer of x, and we're going to have we should have 2 roots here. So we got to be careful on what we're going to put in x, because here's the tricky part of the problem. And here's where you actually have to set aside, we're going to cancel out a solution, this one. So we're going to do the subtraction first. So we have minus 12 minus 15. Well, 12 plus 15 is 27. And then we have 2 negatives, so we just slap on a negative. We have negative 27 as one of the roots. And then if we do negative 12 plus 15, we get 3. Now I want you to analyze one of the roots here and tell me which one is x, or both if they're both x, and just tell both 3 or negative 27. I want you to solve this part of the problem. Alright, so hopefully you've decided on what the solution is going to be. I take a look at 3 and I can tell that maybe it's 3. But when I take a look at negative 27, I'm not sure how we're going to have a negative 27 over here. Because if it's a side length, it has to be positive. There's no way a side length can be negative. In this specific problem, there's no way, unless he's subtracting it. But in this case, if he does 14 minus 27, he's going to get a negative number, which I'm not sure how you can have a side length of a negative number. So in this case, this solution makes no sense in this problem. And here's where this comes in. This polynomial equation right here, the quadratic equation, this was just meant so we can get our value of x. This was just made to help us. And when we turn a geometry problem into an algebra problem, we have to be a little bit careful, especially with multiple roots, especially when you have polynomial equations. You can have multiple roots, stuff like that. When you use algebraic manipulations, you might have multiple roots in polynomial equations, so you have to be careful with this stuff. So we have 3 as a solution. Now x is equal to 3. We've figured out x. And I can erase this right here. We already know x is equal to 3. Now let's plug in x. 10 plus 3 is 13. So I'll draw like a mini replica of this is 13, and 14 plus 3 is 17. Now we know that 17 is greater than 13. So we know that the greater side length of the larger pen is going to be 17. So 17 is our answer. 17 is our answer. So hopefully this video was helpful, and yeah.